Question 45, we've got this golfer hitting this ball at 35 meters per second at an angle of alpha. And so splitting that horizontally and vertically, horizontally I've got 35 cos alpha, and vertically I've got 35 sine alpha. We don't know what alpha is. But we do know we want this thing to go 80 meters along, and we want it to go 5 meters up. So let's look horizontally first of all. Because horizontally, if I want to go 80 meters, well, 80 meters is just the speed, the velocity, times by the time. And from that, I could actually say what t was. T is equal to 80 divided by 35 cos alpha. Park that for a minute. Now let's go vertically. Vertically, the distance we want is 5. So I'm actually using an s equals ut plus half at squared here. S we want is 5. U, the initial vertical, is 35 sine alpha. And t, well, t is this one. T is 80 over 35 cos alpha. So plus, or rather minus, half a, so I've got 9.8, half of 9.8 is 4.9, and then now we've got t squared, and t is this one here, 80 over 35 cos alpha all squared. Pretty yucky. Look, those 35s there are going to cancel, and then I've got 80 here, and I've got a sine alpha over a cos alpha, and so there I've got a tan alpha. Now I can do some tapping here. I can do 80 squared divided by 35 squared times by 4.9, and that gives me 25.6. But it's also giving us a cos squared on the bottom. And of course, cos squared on the bottom is a sec squared alpha. And suddenly now some of our core maths, our pure maths, is coming in. That you should remember that sec squared is the same as 1 plus tan squared. And if we put that in here, we can get a big long quadratic, all in terms of tan. I've got this, I've got 25.6, and I've also got 25.6 tan squared alpha. The quadratic I'm getting then, I'm going to add this over here, 25.6 tan squared alpha minus 80 tan alpha, and then I'm going to get plus 30.6 there, equals 0. On my quadratic solver, that tells me that tan alpha can be 2.6787, and the other one is 0.4462. The question asks us for the largest angle, so if I then inverse tan of that, and the inverse tan of that is 69.5 degrees. How likely are you in actually landing on the hole? Well, very unlikely, because we didn't consider any factors other than the just simple maths of it. So there's no air resistance, there's no sort of knowing that the golfer, can he really do 35, can he really do alpha, the size of the ball, that we've taken it as a particle, all those normal reasons.